Okay, good morning students. So we are now here through our different problems in solving arithmetic sequences. So let's have to solve this kind of problem wherein you're asked to determine the first 5 terms of each sequence. So I have here a sequence which is a sub n is equal to 2 raised to the power of n minus 1. So we are asked to find the first 5 terms. What are these first 5 terms? So you have a sub 1, that is the first term, your a sub 2, that is the second term, your a sub 3, that is your third term, a sub 4 is your fourth term, and the fifth term is a sub 5. So we are asked to find the values of the first 5 terms given a sub 1, a sub 2, 3, 4, and 5. So to solve the following, or to solve this kind of problem, okay, we just simply solve first your a sub 1, that is the first term. So in order to solve this problem, we just simply substitute the value of your n to the formula. Okay, so we are here a sub 1, so a sub 1, which means the value of your n here will be substituted by 1. So therefore, copy 2, and then from the formula n minus 1, so therefore your n is equal to 1 man, so it becomes 1 minus 1. Okay, so then simplify. Please take note, you need to simplify first the exponents. So therefore, you copy first 2 and then simplify the exponent 1 minus 1. So what is 1 minus 1? That is equal to 0. And 2 raised to the power of 0, according to the laws of exponent, is equal to 1. So that is the value of your first term, or a sub 1. Okay. So therefore, your a sub 1 is equal to 1. So let's go now to your a sub 2, or the second term. So if you have a sub 2, which means the value of your n is equal to 2. So again, copy 2, and your n is equal to 2, so that is 2 minus 1. So again, always solve first the exponent according to the PEMDAS rule. So you have here 2 minus 1 is equal to 1. Okay, so 2 raised to the power of 1, that is equal to 2. So your a sub 2 is equal to 2. So right there, 2. At this point, you're now going to solve for a sub 3. Okay, so a sub 3 is what you call the third term of our sequence. So again, a sub 3, which means the value of your n is equal to 3. So copy first 2, again n minus 1. So since your n is equal to 3, so it becomes 3 minus 1. Right? So again, simplify first with the exponent according to the PEMDAS rule. Copy 2. 3 minus 1 is equal to 2. So at this point, if you have now the answer, okay, so if you have now the answer, what is 2 raised to the power of 2? Okay, that is equal to 4. So 2 raised to the power of 2 is just equal to 2 times 2. So your a sub 3 is equal to 4. Okay, so you write there, a sub 3 is equal to 4. Okay, so at this point, let's go now to the fourth term, or what you call a sub 4. So we all know that a sub 4, the value of your n based on your specific formula or problem that is given, your n now is equal to 4. So which means copy 2. From your n minus 1, it becomes now 4 minus 1. Okay? So since we need to simplify first the exponent, so we copy 2. 4 minus 1 is equal to 3. Right? So what is 2 raised to the power of 3? So that is 2 times 2 and times 2. So which means 2 times 2 is 4. 4 times 2 is equal to 8. So which means your a sub 4 is equal to 8. Right? So let's go now to the a sub 5, or the fifth term and the last term. That is actually atong gipangita. So if you have a sub 5, which means the value of your n is equal to 5, right? So which means from here, you copy 2, and your exponent is n minus 1. That becomes 5 minus 1 since our n is equal to 5. Okay, again, simplify first the exponent. 5 minus 1 is equal to 4. So what is 2 raised to the power 4? So that is equal to 2 times 2 times 2 times 2. So 2 times 2, 4. 4 times 2, 8. 8 times 2, that is 16. Okay? So your a sub 5 now is equal to 16. Oh, I forgot to write your a sub 4 here. 8. So these are now the values of the 5 terms given the formula a sub n is equal to 2n minus 1. So again, we are asked to determine the first 5 terms of each sequence. And we all know that the given terms are given a variables of a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Okay? Thank you.